So that's good. I'm going to store that away in the back of my mind. In order to use that, I need a kind of equivalent thing for particle B, right? So I'm going to go all the way back to the beginning. I'm going to consider particle B now. And in some ways, this part is a little bit repetitive because I have to repeat this process, okay? I'm going to say that velocity is the change in displacement over time. So I've got this statement here for a different particle now, right? So this is, what have I got? -4, 16, take away. Just like before, I'll take reciprocals. And then, of course, I need to integrate in order to get to a displacement equation that I can pop a time into. Okay. So, having written this integral, I'll chuck that constant at the front. Morning. I've got this as my integrand, which we ought to. Oh, that should be a b. Sorry, keep missing that. Which we ought to recognize as which standard form? What are we looking at here? This is sine inverse, or alternatively cos inverse, but as you guys know, it doesn't matter. So I'm going to use sine inverse here, and I think that's fine. I've got the -1/4 as a constant hanging out the front. What's this going to become? xd on 4, right? And there's a squared minus x squared in there that we saw before, okay? And then I've got another constant because it's still an indefinite integral, okay? So let's just say that's some real number. Okay, lovely. Now, have a look at this. Pause for a moment. What can I do with this? You've integrated successfully. Last time, you used this initial condition in order to work out what the constant was. What are you going to do now? What are you going to do now? Because I don't actually have an initial condition for x and b.
1 t equals pi 16.
Okay, so last time, right, I knew initially where I was starting from. But where this guy initially, that's the question. So of course I don't know that, right? I don't know where I start, but I do know where I'm supposed to end and how long it's going to take me to get there. Okay, so I guess it's an initial condition versus a final condition. Okay, so instead of using t equals 0 to evaluate this constant, I'm going to say for particle B, to do the same thing here, to reach the origin, simultaneously with A. That's what I'm after. That word simultaneously, it allows me to use these two facts together. A displacement and a particular time. Okay, so that's what that word means to me, and that's what I'm going to put in here. Okay, I think I'm going to slightly run out of space, so I'll do it over here. I'm subbing in time equals pi on 16. I'm subbing in x of b equals 0, and that should allow me to find the constant. Okay, so in other words, what I'm going to get is -1 on 4 sine inverse of. This is 0, right? This is 0. There's the constant that I'm trying to evaluate, and this is how long it takes me to get there. Yeah. Sine inverse of 0, of course, is 0. So I just get the same constant that I got before. That's kind of nice. So for the second particle, for particle B, I now have a complete displacement time equation, right? So this is going to be -1/4 sine inverse of that plus a constant. Okay, I'm almost there. I'm on the final leg. What do I do with this thing? What am I trying to solve? Yeah, initial condition. Like, where am I supposed to release this thing from? So at time 0, what is, excuse me, what's going on? Okay, so therefore, initially, when I put time 0 into here, I'm going to say -1/4 sine inverse of that thing which I'm trying to find out. That's where am I going to release from? Plus pi on 16. That's time 0. Right? Does that make sense? So I just need to tidy this up a tiny little bit. It looks to me if I put this guy on the other side, but then write him on the left, because the thing I'm trying to find is nestled within that sine inverse. I've got this. I can multiply through, like so. Okay. Now, don't just jump to the next line. Don't just jump to the next line. Think about what I'm going to have to do. And I want you to notice that you can't always just do that operation you're thinking of that's in your mind. What do I have to do to both sides?
Sine.
I have to take sine of both sides, okay? Now you're probably thinking, oh, well, sine inverse, sine, I can just write down xv on 4 equals sine pi on 4, which is 1 over root 2. I would think, oh, that's what I'm going to get. It is what you're going to get, but you can't just do that, right? We looked at what happens when you put together trig functions with their inverse trig, reverses, okay? Sine of sine inverse of something is not always just that thing, okay? Sine of, I actually have run out of space. I'll write it here. So just view this as a separate thing. Sine of sine inverse of whatever you like, let's just say some number, k, okay? It is equal to k, but only sometimes. Think back to your inverse trig. There's a restriction on this. What is it? Okay, so it's the restriction that exists on this guy, right? Like this guy doesn't exist everywhere. He only exists in a certain few places. For example, if I said to you, hey, sine inverse of like 5, that doesn't work because there's no value, there's no angle you can give me that sine of that will give you 5 because, of course, the restriction on sine inverse and cos inverse is going to be from where to where? Negative 1 to 1, okay? Negative 1 to 1, bless you. Okay. Now, hold on a second. Is that okay? This seems to me like it's a bit of, initially when I look at this, seems to be a bit of a problem, right? Because in fact I'm not between negative 1 and 1. Am I? Isn't that a problem?
Because divided by 4.
Aha. So, luckily for me, and this is why all these numbers are the way they are, right? I'm not actually having sine of sine inverse of some arbitrary number. I have sine of sine inverse of this divided by 4. So actually you can write this line, which is absolutely true. And from that you can conclude, well, sine of sine inverse of what I'm actually interested in is x of b on 4. Now, when is that x of b on 4? And the answer is, it's when x of b on 4 is between negative 1 and 1. But that's okay, right? Because look, negative 4 to 4, the first thing I want to point out is that's okay with this. But the second thing I want to point out is I actually should have written down that lines and lines and lines ago. Where? Where should you have already known that was the case? Look carefully.
Is it the time?
The first time we talked about particle B, the second we wrote that, we should have noted there was a restriction, right? Because look, you got a square root under here, you got take away x squared, so x can't just be anything you like. If x is too big, its absolute value, then you're going to get a negative under the square root. We're in real land, right? So the second I wrote this, I really should have said, right, have a look, that thing under the square root, the smallest it can be is 0. After that, I'm in trouble. So therefore, I could have noted this at the beginning. Okay, and this is what rescues us over here. Let's come back to our final working. Over here, I can say this because I have a restriction on x of b. So I actually can. This is a legitimate line of working. Just like we've been looking at in inequalities, you can't just multiply and divide by or apply functions just because you want to. You have to know, oh, all my numbers are real, or I have some kind of restriction on x, which lets me do this. Okay, so I'm going to invoke that. Negative 4 to 4. Okay, and then finally that lets me get to finish off. And you can tidy that up if you want by saying, therefore, we need to release particle B 2 root 2 units on the positive side of the origin. And that's it. Okay.